Hi, welcome all. My name's Christopher Jackson. I'm one of the co-founders at Advanced Infrastructure. This is a dissemination webinar for the learnings from a 3-month feasibility study sponsored by BASE, exploring the use cases for a smart meter data repository, the cost-benefit analysis, and the technical solution prototype. There will be a Q&A session at the end of this 15-minute presentation, and you're welcome to put your questions in the chat. First of all, we're starting off by what is a smart meter data repository and why do we need one? In this slide on the in the center, you can see the smart meter system divided into 3 components. First of all, on the left-hand side, there's the consumer-facing component, or the energy users. And most of you will be familiar with what a smart meter what a smart meter is in your homes. It collects on a half-hourly basis energy consumption and transmits that back to your energy supplier. But you should also be aware that there are other components to that, which can be in-home displays, which allow you to view your energy consumption and often your energy cost. There are also smart applications, increasingly on mobile phones, which allow the consumer to engage in analytics, to explore how to reduce their energy consumption and to have detailed reporting. This is applicable both for the domestic and the non-domestic sector as well. And by that, we mean businesses with energy supplier contracts. In the center, we have the communication infrastructure, which is largely based off a version of the mobile phone network to be able to transmit small packets of information on a regular basis between the consumer smart meter and the energy supplier, predominantly for billing purposes. To give you an indication of scale, there are about 1 billion messages transferred per day, a combination of energy consumption data, but also system data, which will be the status of the meter, tampering alerts, voltages of the meter, various different types of information. And finally, on the right-hand side, there's the end users of this data. Predominantly, that would be energy suppliers, so they can accurately bill your energy consumption, but also increasingly energy network operators, gas and electricity distribution network operators who use the data to optimize their network. And increasingly so about 50% of users at the moment are authorized third parties or other users. So we have these 3 distinct roles accessing the energy data, the smart meter data for different purposes. So just going through the 3 items again, a coverage of the smart meter network is above 50% in the UK, so more consumers have smart meters than don't, and that rollout is predicted to continue into the 2030s. There are at least 3 different types of roles by which end users access this data. And finally, why we need a smart meter data repository is because there is no actual store of the energy consumption data and the meter system data. Essentially, the communication network transmits the messages directly between the smart meter and the end user, but doesn't store that data. And this was originally done because of data privacy and data security concerns, but that is also problematic because if anyone wants to analyze and use smart meter data, they therefore have to then build their own connectors and begin storing their own data before they can do this. So it's typically seen as a technical barrier to the exploitation of smart meter data. So in conclusion, the smart meter system is a rich source of energy-related data, but this data is effectively distributed across millions of meters that generate and store it. The technical and regulatory barriers prevent access and utilization of data effectively and efficiently. And this may act as a barrier to, for example, smart energy planning, smart energy innovation, and the development of demand-side response services. And therefore, we've explored the use of a smart meter data repository. So moving on, it's worth noting that the smart meter rollout was planned back in the 2010s, and before any expensive decision is made, any policy decision is made, typically central government will undertake a cost-benefit analysis. The latest version of that cost-benefit analysis was essentially refreshed in 2019, and they identified net benefits to the UK of £19.5 billion through the rollout of smart meters, essentially upgrading the entire network from physically read meters to remotely read meters. In our analysis, we were interested to see what would be the additionality of building a smart meter data repository to store that data rather than allowing it to remain distributed and uncollected on the smart meters themselves. So we were very conscious of observing how the 2019 refresh of the cost-benefit analysis was done. And we took the following approach: that we identified three types of benefits. The first one would be a cost that the smart meter energy data repository can save by collecting the data and avoiding the repetition of it being collected by multiple users. The next type of benefit were those that we thought extended the value and existing benefits identified in the 2019 cost-benefit analysis. And the third type were new benefits that have emerged since 2019 that haven't been quantified in the 2019 cost-benefit analysis. And in doing that, we identified about £1.6 billion of additional benefits that the smart meter energy data repository would bring, just attributed to itself. But we also saw wider benefits in our analysis and refresh of the cost-benefit analysis, which we've termed the CBA 2023. Now, it's worth noting that our version of a very robust cost-benefit analysis doesn't compare in detail and quality because of the short duration of this project. But we've attempted to refresh the cost-benefit analysis so we can try and be more accurate in determining what benefits would have taken place in the counterfactual should the smart meter data repository not be created, and what benefits are only enabled due to the smart meter data repository. So one thing to also mention as well is that the cost-benefit analysis that we have undertaken has followed the Treasury's Green Book, and they have this is important because they have specific instructions and guidance on how to measure costs and how to essentially sum them over a particular assessment period. So we've tried to align with that methodology as much as possible. So we only consider benefits between 2023 and 2034, 2034 being the cutoff point for the 2019 cost-benefit analysis. So on the next slide here, you see the results of our analysis. what you have on the left-hand side is a table of benefits, 6 benefits or groups, families of benefits identified in the 2019 study across consumer benefits, supplier benefits, demand shifting benefits, network operator benefits, carbon and air quality benefits, and wider benefits. And you'll see the first column refers to the 2019 cost benefit analysis, in which those original 19 billion pounds of savings were identified. It's worth pointing out 2 things here that I'd like to draw your attention to that are reasonably commonly understood around the limitations of that 2019 cost benefit analysis. The first one is that the largest cost saving was attributed to energy savings. And the rationale was that if consumers, both domestic and non-domestic, are able to see their half-hourly consumption and the cost of that consumption, then they are more likely to undergo behavioral change and reduce energy consumption. Now, a number of studies were undertaken to try and quantify the percentage of energy reduction, and those range between 0.5% up to 10%. So there's quite a large range, and therefore the sensitivity of that largest benefit of energy savings, 1.1, is very dependent upon the consumer's behavior, and that should be flagged. And it's increasingly we're seeing additional services and innovations to try and influence customers based upon the use of mobile phone apps, replacing increasingly in-home displays, which were seen as not successful as they were once thought to be back in 2019. That's why we've identified energy savings attributed to the smart meter data repository to be quite considerable, because it enables those mobile solutions to provide a better service than they would do without the smart meter data repository. The second point we'd like to make around the 2019 cost benefit analysis was around demand shifting benefits. Again, a very substantial benefit of 1.4 billion, but that was exclusively attributed to the transmission network, and it did not consider the distribution network. We think that is now unwise, because more and more solutions are being developed leveraging digital twins of the distribution network, and those digital twins need more and more data in order to make them more and more effective. So we think that there should be a revision of the demand shifting benefits to include more attributable to the distribution networks. The next slide shows the table of benefits and use cases that we have identified in the 2019, in the cost benefit analysis that we attribute to the smart meter data repository. Putting out a few of these, I want to make the first point is that some use cases already had access to smart meter data, but this was limited by non-technical barriers to accessing the smart meter data, such as consent and anonymization. So I'm going to pick on another use case here, which is bill disaggregation. So that's 1.4. So in this use case, third parties can access smart meter data for the purposes of aggregating and disaggregating the bills for additional reporting. And an interesting example we came across was for carbon emissions reporting. In this use case, companies such as Hearst and others would access large portfolios of smart meter data for the benefit of, let's say, mortgage book providers in order to calculate the carbon emissions associated with those portfolios of properties. Now, it's worth observing here that the mechanism of consent that they were using was effectively external to any Ofgem regulation and was based upon legitimate interest. That being that mortgage book providers need to be able to report the carbon emissions of the buildings that they own or fund. So this was an example of an innovator using an alternative consent mechanism in order to facilitate the execution of this use case. Another example I want to look on is that some use cases found accessing smart meter data expensive due to the need to build connectors to the SMS network. And this example, I'm going to call on 4.1 and 4.7. In the case of 4.7, distribution network operators need to know which buildings are connected to which phases of an electrical cable and which feeder of a transformer. Often this is not known because historically buildings have been connected before there was a reliable digital mapping of the energy system, and many of these records have since been lost in the past sort of 20 to 50 years. So a significant percentage of the network is essentially unmapped. The means of mapping it would be through physical inspection, but there is an alternative, and that is to use smart meters to assess the voltage of the connection of each property, and therefore one can infer by voltage drop calculation how many buildings are connected to each feeder or to each phase. So this is a particularly useful use case for distribution network operators, which we valued at £145 million for the remainder of the appraisal period. Now, what we found was that there were two technical barriers to deploying this solution. Firstly, each distribution network operator needs to build and manage their own connector to the smart metering system network, which incurs a significant cost. And that was simply replicating efforts throughout the industry, with quite considerable costs between sort of 10 to 20 million pounds for the creation of those connectors and a significant fee for running them thereafter. The other barrier was that providers of digital solutions need to be able to train and improve their solutions upon not just one customer's data set, but multiple, in order to improve the accuracy of their solution by observing and validating against different geographies and different regions and different network topologies between hybrid ones and radial networks, because the performance of these types of solutions in different regions can vary. So therefore, there was a technical barrier in these innovative providers being able to access smart meter data from other regions to which they don't they don't yet have customers, and that reduced the performance of the solution that they were trying to sell and develop. So this leads us to have three recommendations coming out of the feasibility study. First one is to build a smart meter data repository due to the high net present value from the exploration of the use cases, estimated about 1.6 billion, as we mentioned earlier. The costs of a smart meter data repository were found to be small. We believe less than 10 million to construct a nationwide scale smart meter data repository, and ongoing costs of less than £2 million to operate. So a clear benefit when compared to the cost. Our second recommendation was that the prototype demonstrates the legitimate interest use case in order to open up access to a wider number of market participants, ensuring fairness, competition, and innovation can be delivered for all. So we believe that it's not just a technical solution that's required, but it's also a better understanding and demonstration of other mechanisms of consent and access to the smart meter data repository, and explicitly those that rely upon existing GDPR law rather than those being constrained by the existing regulations specific to the energy sector. So the more of these use cases that can be demonstrated, the more confidence is built by innovators and their potential end users that this is a viable method of accessing smart meter data. And the third recommendation is that the prototype demonstrates quantitative measurement of the risk of re-identification of anonymized data to allow data processors to make better use of anonymized data to benefit the sector. So again, it's not just the technical solution that's required, it's the industry understanding that it's okay to anonymize data. In our research, we found that there was a very conservative approach to anonymization methods, which meant that to a large degree, most of the useful information around half-hourly energy consumption at the building level was lost. So what we propose is that alongside the technical solution, there is also a methodology proposed for identifying the risk of re-identification of any anonymized data. So that was the summary of the research that we found so far. I would invite anyone on the call to ask some questions, and you can do so by submitting that in the chat. But I would also start off by two questions that we previously had asked by other participants. And the first one was, what were other countries' approach to smart meter data and the handling of it? The focus of this feasibility study was on the UK, but we do have some general awareness of how smart meter data is treated in other European countries, because many of the participants that we interviewed had subsidiaries overseas. I mean, it's worth pointing out that a few sort of structural differences. First of all, in Spain, we understand that smart meter data or half-hourly energy consumption is not considered a personal private information or personal identifiable information. So therefore, all participants are free to use it. And it's interesting because some of the innovative solutions are coming out of Spanish companies are more advanced than UK ones because of the access to smart meter data, especially for delivering solutions to distribution network operators. The other observation we found is that there are different market structures. So in France, for example, there are many sort of nationalized energy and utility combined providers which have ownership of the entire vertical, which would imply that exchanging information within that vertical is far easier. Comparing that to the UK, we have a transmission network which is owned by a separate operator to a distribution network, which is owned by a separate operator to an energy supplier. So there are more commercial barriers preventing the exploitation of smart meter data in the UK than there are in countries such as France. And conversely, in Germany, it's actually the opposite. There are far more local distribution network operators, 50 plus in Germany compared to only 6 in the UK. So there's more fragmentation in the industry. So that would be our observations on other countries. Another question we had was, how do customers feel about their energy consumption data being shared? And the research we gathered on this was that recent research shows that actually the concern around the use of energy data has subsided in the mind of the public, and they're far more relaxed about the usage of their data for the benefit of the energy sector. Additionally, quantitative research that we did when we were building an approach to trying to quantify the risk of re-identification, also pointed to the fact that one of the principal concerns around exposing half-hourly energy consumption at the domestic level was the risk for a not-at-home identifier being abused by, for example, for home burglary. And we made the observation that most of the use cases, or many of the use cases, which involved analytics of smart meter data, didn't require real-time data and used historic data. And in that case, the risk to a homeowner that they are identified as not being at home isn't really the case. And much of the value of smart meter data can actually be leveraged with historical data. In the commercial sector, historic data does remain a bit of a commercial risk because it can show energy consumption patterns which might be commercially sensitive. But it is worth noting that commercial data isn't governed by the same GDPR regulations as domestic data. So, do we have any further questions from any members of the audience? I'll give you just a minute to try and tap them through. So I can't see any more questions coming through, but I will. I do welcome any of you to reach out to me. You can find my email address on the shared on the screen at the moment. It's christopher@advanced-infrastructure.co.uk. Please do reach out to me if you have any further information. Also, this webinar is being recorded and it will be available on our website. So we will send out links to those who couldn't attend. So please do feel free to review this presentation and the slide deck associated with it. If you have any further questions, we'll be very happy to engage with you. Okay, well, thank you everybody for attending. It's been a really interesting session, and I look forward to engaging with you in the future.